Very good morning. I'm Rick Biswas, the team leader of Team CodeVerse, and we are participating for the Kavach Hackathon 2023. And the problem statement that we have chosen is New Age Women Safety App. So, moving to the first slide. So, in this slide, I'll discuss our approach towards the problem statement that we've chosen. Now, if I had to describe our problem statement in a nutshell, basically, we'll have to develop a mobile application which will help us sense any type of potential threats or dangers to the women user, and it would raise a SOS distress signal in situations where the user is unable to use her mobile. So basically, when the user is unable to operate her mobile, we have to continuously fetch sensor details from the mobile. For example, we'll have to fetch her video, the audio, accelerometer, GPS signals, etc. from the mobile. Now, from our end, we have included that smart wearables like smartwatches and etc. are very common nowadays, and which can help us exponentially when we are thinking of SOS signals for the safety of the women. So basically, from the smart wearables, we will get important data like her body vitals, for example, her heartbeat, the oxygen saturation of her blood, and her accelerometer data, which will basically signify the motion that the user performs. So our approach includes initially the user will register in our application, and during her registration process the user will be asked to upload some emergency contacts, for example her father's number or her cousin's number or her roommate's number, like any person who can be readily available in case the user is facing any potential threat. So that's the step that we are including in the registration process, and we will take periodic data from the user. For example, we'll ask the user to upload pictures of her familiar faces, for example her friends, her professors, or maybe her family members, or her her boss, or you know her fellow office mates, etc. And we will develop a model. Using that model, we will record her regular behavioral patterns. Behavioral pattern includes the rate at which she usually walks, the rate at which she usually runs, or the way she climbs down the stairs, and data like the voices that her family that are heard from her mobile devices. For example, her professor's voice, her boss's voice, her friend's voice. So all of this data will be periodically recorded from her mobile device, and it will be used to train a model. The job of the model is to get a signature pattern which would very closely determine the way the user behaves on a regular basis. Now the part that is our SOS detection. For example, the user goes on a morning walk. So we would record the rate at which she is walking, and the rate at which her heart rate varies according to the way she runs. Okay. Now basically, when we are running, the our heart rate means it increases, but it increases regularly, and we can confirm her running activity along with her accelerometer data, because we can get a acceleration in the x-axis. So regular activities like running would have a certain behavioral pattern, and for example the user is being harassed, so the jerk that will be experienced by her mobile phone would be very different from the way maybe she's skipping or running. So that's something that we can analyze from her behavioral patterns. Now we are using multimodal data. As we have said, we are using voice, audio, video. So we need to define a threshold. The threshold is basically the situation after which we can conclude the current activity as a potential threat to the user. So as the user will use the application, her the threshold value will be adjusted accurately the more the app is used. Now, let us consider a situation where the user is being harassed, where she is victim to any potential threat activity. So in that case, the live behavioral pattern that is recorded by the model would be very different from the signature behavioral pattern that is stored in my database. So in that case, I am registering a possible threat. Now I cannot raise a distress signal based on a possible threat because the model might not be very accurate initially, and if a false distress signal is raised, it can be a harassment to the police authorities as well as her emergency contact. So the next thing that is very important to us is verification of the possible threat that is imposed on the user. So for the verification purpose, we would uh, we would kind of activate an emergency mode in the cell phone or the smartphone. Basically, camera feed will be enabled at that time, and the microphone would be listening for code words like help me or anything that signifies the user in a distress situation, for example help or save me, anything like that. So if these words are detected, a notification would be raised on the user end that are you in an emergency situation, please respond to this notification with a given time, or this situation would be declared as an emergency and your emergency contacts will be notified. If the user is unable to respond to that safety notification, we consider it as a red flag, and we use the camera device to spot unfamiliar faces. As I said initially, the familiar faces are recorded. The familiar faces are uploaded periodically by the user, and using image processing, we can detect whether the frame that is recorded by the camera involves the user or the familiar faces in any manner. So if we can detect one or more familiar face, we discard the potential threat request. But in case I'm unable to fetch the camera feed, I use other feed as well. For example, the accelerometer of the phone and the accelerometer used on a smartwatch. And using a combination of these, I can understand. For example, if the user is being harassed, if unfortunately if she is not given the ability to speak, we can use the accelerometer data because the jerk that she will be experiencing will be very different from the jerk she's experiencing under normal situations. So in that case, a distress signal will be raised, and her and the nearest police authorities and emergency contacts will be uh, informed about her situation, and they will be shared the live location as well as the live audio feed of the victim. Now, in that situation, the phone goes into emergency lockdown, which basically means that the user, means anyone except the user, cannot turn off the location and the internet of that device for security concerns, because these parameters are essential for the police authorities as well as the emergency contacts to track her down. So that was the approach in a nutshell. Now I will briefly describe the technology stack. So as our approach involves a lot of machine learning algorithms, we will use Python for the backend, and we can clearly understand that our problem statement involves an Android application. So we will use Java for that purpose. We are going to use some cloud services because our problem statements involves sharing of live location feed and live audio feed. So we will use relevant cloud services. Twilio is an API service which will be used whenever we are detecting the false alert notification. And the job of the admin is to fence the geographic locations of the police station. So basically, we will give an admin dashboard to the admins, and that will be a web application. So it will be designed using React.js. So moving to the next slide. Uh, our approach is briefly jotted down in the form of the flowchart, which involves the user, the admin, and the emergency contacts of the user. So it involves many modules. For example, the registration module, which involves the user registration, safe environment training module, which is the behavioral or usual behavioral pattern of the user, and the live data monitoring module, which will take the live feed and it will monitor it for any type of potential threat activity that can be detected. And signature pattern generator is the signature, that is the usual lifestyle pattern of the user, which will be rectified over the time. And we can see the other features. One thing that I want to mention is the uh, the smart wearable devices will not directly share the data with us, so we can use Google Fit API to access the data from the smart wearable devices, and we can use the Android application to directly dig into the sensor data. If I speak about the use case, the four basic use cases of our application is the detection of the lifestyle trends of the user, detection of any potential threats that she might be experiencing, analysis of threats, which is basically verification that the potential threat I have detected is a real one or not, and finally alerting rescue authorities with relevant information so that we can prevent any type of mishap that is happening with the women victim. If I had to describe the dependencies, the dependencies are very minimal, which is a good and stable internet connection, because our application involves sharing of live feed and as well as some processing algorithms. So that was all about our problem statement, our approach, and our idea. So now we'll go to the details of our team. So our team involves Shrinja Ghosh from IT third year, Akansha Prasad from CC third year, Devangi Nath from IT third year, Rasha Alam from IT third year, Shubhabrata Malik from IT third year. Our team is mentored by Professor Dr. Shilata Munsi sir. And finally, I'm Rick Biswas, the team leader of Team CodeVerse. Thank you and have a nice day.